Good morning to all. Welcome to Sigma e-learning smart way to excellence. The topic we will discuss today is Introduction to Trigonometry. What is trigonometry? Trigonometry is study of angles and sides of a right angle triangle. Let us demonstrate what are the right angle triangles in our real life we have observed. For example, let us imagine this is a mobile tower. This is the person who is observing this mobile tower. This is the distance between the mobile tower and the person who is observing. This is the distance between the top of the mobile tower and the observer. So this will be the height of the mobile tower. For example, it can be a vertical structure, it can be a mountain, it can be a current pole, it can be any stick also. Let us discuss two cases of two right angle triangles here. For example, this is a one right angle triangle. Let us imagine BC is the any vertical structure. The AB will be the distance between the observer and the vertical structure. This is the distance between the top of the vertical structure and the observer. So it has the shape of right angle triangle with three sides and three angles. Observing from this point, so the directly opposite side became the opposite side. It became the adjacent side. It will become hypotenuse. So this is all about this triangle. See here in this case, the observer is observing from this point to this point. So this is the directly opposite side to the observation. So I can call it as the opposite side. This will become the adjacent side. This will become hypotenuse. Simple. The only difference between this triangle and this triangle is the observer in this triangle observer is observing from this point, but in this triangle observer is observing from this point. Our mathematicians propose different names for the different ratios of right angle triangle. We will discuss one by one here. The sine of A is opposite side by hypotenuse, and the ratio of adjacent side by hypotenuse is called as cosine of A. The ratio of opposite and adjacent became tangent of A. We know that opposite side is BC, adjacent side is AB, hypotenuse is AC from the given above figure. It will become BC by AC. Why? Because opposite side is BC, hypotenuse is AC. In the same manner, cosine of A equal to adjacent side by hypotenuse. So it is AB by AC. For the tangent of A, this is opposite side by adjacent of. For tangent of A, this is the ratio of opposite side and adjacent side. So it will become BC by AB. Okay. These are three major important ratios. The sine of A is opposite side by hypotenuse. The cosine of A is adjacent side by hypotenuse. The tangent of A is opposite side by adjacent side. Okay. Cosecant of A equal to 1 by sine A. Why? Because the sine of A and cosecant of A are reciprocal with each other. So I can reverse the sine ratio, means it will become hypotenuse by opposite side. See here, hypotenuse by opposite side. So it will become AC by BC. Okay. Secant of A. Secant of A is the reciprocal of cosine of A. Secant of A is the reciprocal of cosine of A. So it will become reversed. Hypotenuse by adjacent side. So it will become AC by AB. Cotangent of A is nothing but the reciprocal of tangent A. So it will become reversed again. Adjacent side by opposite side. See here. Adjacent side by opposite side. So it will become AB by BC. You must remember these three ratios. Remaining ratios must be extracted from these three ratios. Simply, the sine of A is opposite side by hypotenuse. The cosine of A is adjacent side by hypotenuse. The tangent of A is opposite side by adjacent side. So cosecant of A is simply the reciprocal of sine of A. So it will become opposite, hypotenuse by opposite side. The secant of A is the reciprocal of cosine of A. So it will become reverse, means hypotenuse by adjacent side. The cotangent of A is the reciprocal of tangent A. So in this manner, we can easily remember all the ratios. These are few more formulas must be remembered by you. So tan A equal to sin A by cos A. Cot A equal to 1 by tan A, which is equal to cos A by sin A. So cosecant A equal to 1 by sin A. Secant of A equal to 1 by cos A. These are what is reciprocal means just numerator became the denominator and denominator became the numerator. See here, for example, what is the reciprocal of 4 by 5? So simply it will become 5 by 4. Just numerator became denominator, denominator became numerator. Point number 4, the values of trigonometric ratios of a triangle do not vary with the lengths and sides of the triangle. The angle remains the same. Means, consider these two triangles. This is one triangle, this is the another triangle. The sides of the triangles are vary with each other. So the sides of this triangle is different from the sides of this triangle, but the angle of observation is same for the both triangles. So in this kind of cases, the trigonometric ratios are same for the both right angle triangles. Why? Because the angle of observation is same. So let us discuss the Pythagoras theorem. What is Pythagoras theorem says? The Pythagoras theorem says that the square of hypotenuse is equal to the square of opposite side and the square of adjacent side. So in this given figure, the hypotenuse is the C, the opposite side is the A, adjacent side is the B. So hypotenuse square equal to adjacent square plus opposite side square. Example 1, given tan A equal to 4 by 3, find the other trigonometric ratios of the angle A. So in the problem itself, he gave that tan A equal to 4 by 3. We have to find the remaining trigonometric ratios. Remaining trigonometric ratios means we have to find out sin A, cos A, secant A, cosecant A, tangent of A, like this. Okay. Example 1, given tan A equal to 4 by 3, find the other trigonometric ratios of the angle A. So he is given tan A equal to 4 by 3. We know that tan A equal to opposite side by adjacent side. Okay. So this is my observation point. So this is the angle of observation. Exactly opposite side, it will become the opposite side. It will become adjacent side. Okay. In the problem itself, he gave that tan A equal to 4 by 3. So the opposite side is 4k. The adjacent side is 3k. Why I am taking the k here? Because in the problem, he is talking about the ratio. So I can consider multiplication of k here. From the given data, we can say tan A equal to 4 by 3. From the subject, we know that tan A equal to opposite side by adjacent side. So opposite side became 4k and adjacent side became 3k. By using the Pythagoras theorem, we can find out the hypotenuse. We know that the hypotenuse square equal to adjacent square plus opposite side square. So AC square is the hypotenuse square equal to, we know that AB equal to 3k, BC equal to 4k. So it will become 4k square plus 3k square. By solving from the given data, we can get AC equal to 5k. So this 5k will become the hypotenuse. Now we can easily find out the remaining ratios of other trigonometric functions. Sin A. What is sin A? We know that sin A equal to ratio of opposite side by hypotenuse. So what is opposite side? 4k. What is hypotenuse? 5k. So it will become 4k by 5k. So simply k and k get cancelled. We get 4 by k. Okay. Then come to the cos A. What is cos A? We know that cos A equal to ratio of adjacent side by hypotenuse. So we know that adjacent side is the 3k and opposite side is the 5k. So it will become 3k by 5k. So k and get cancelled. We will get 3 by 5. Okay. We got the sin ratio. We got cos ratio. The tan A already is given. So we have to find remaining. For example, cot A. What is cot A? Cot A is the reciprocal of tan A. We know that tan A equal to opposite side by adjacent side. So we have cot A equal to reciprocal of tangent A. So tan A and cot A reciprocal with each other. So I am reversing this term. Okay. What is adjacent side here? Adjacent side is 3k and opposite side is 4k. So it will become adjacent by opposite. 3k by 4k. This is the adjacent. This is the adjacent. This is the opposite. So 3k by 4k. So in this manner, we got the cot A also. Then come to cosecant A. We know that cosecant A is the reciprocal of sin A. Simply, we have to reverse this term. Here we got the 4 by 5. For the cosecant A, it will become 5 by 4. Why? Because sin A and cosecant A reciprocal with each other. Then coming to the next ratio, secant A. What is secant A? Secant A is the reciprocal of cos A. So we got the cos A as 3 by 5. So the secant A became simply 5 by 3. Why? Because they are reciprocal with each other. So in this manner, just simply finding the sin A, cos A and tan A, we can get easily. Let us discuss another example. In a right angle triangle ABC, right angle at B, if tan A equal to 1, then verify that 2 sin A and cos A equal to 1. Carefully observe the problem given. So a right angle triangle ABC, right angle at B means at point B, it has 90 degrees of angle. So this is the right angle triangle A, B and C. At point B, it is 90 degrees. Also, he is given that if tan A equal to 1, okay, we have to prove 2 sin A and cos A equal to 1. Tan A equal to 1 means the ratio of opposite side and adjacent side is 1. From the Pythagoras theorem, we have to find out the hypotenuse. We know that hypotenuse square equal to opposite square plus adjacent square. By solving, it will become square root k. So, by the Pythagoras theorem, we found the hypotenuse. Now, we know what is opposite side, what is adjacent side, what is the hypotenuse. From the given data, we have to prove 2 sin A cos A equal to 1. So, to prove, we have to first find out the sin A, later cos A, later we have to substitute. Let us find sin A. We know that what is sine? The sine is opposite side by hypotenuse. We know that opposite side is k. What is hypotenuse? Square root k. It will become k. Then k and k get cancelled. It will become 1 by square root 2. Next, come to the cos A. We know that cos A equal to adjacent side by hypotenuse. So it will become k by square root k. K by square root k. K and k get cancelled. It will become 1 by root 2. Now we have to substitute the ratios of sin A and cos A in the given problem. The trigonometric ratios of some specific angles. Carefully examine these ratios. For the sin A, the ratio became increasing from 0 to 1. See here, 0 is the lowest, the maximum is 1. So these values have been increasing from 0 to 1. 0, 1 by 2, 1 by root 2, root 3 by 2, 1. So in this manner, by increasing the angle of observation, see here 0, 30, 45, 60, 90. By increasing the angle of observation, the sin A means the ratios of opposite side by hypotenuse increasing from 0 to 1. But for the cos A, the same ratios decreasing from 1 to 0 means just this entire order got reversed. What is tan A? We know that tan A equal to sin A by cos A. Sin A by cos A means 0 by 1, it's a 0. 1 by 2 by root 3 by 2, it will become 1 by root 3. 1 by 2, 1 by root 2 by 1 by root 2, it will become 1. Root 3 by 2 by 1 by 2, it will become 1 by 3. 1 by 0, it will become undefined. Why it is undefined? The 1 by 0 equal to infinity. We cannot determine the any term. Secant A is the reciprocal of sin A. So, it will become 1 by 0. So, it's infinity. It will become 1 by 1 by 2. It will become 2. It will become 1 by 1 by root 2. So, it will become 2. 2 square root 2. It will become 1 by root 3 by 2. So, it will become 2 by root 3. Just see, observe the pattern. The entire sin A values have been reversing. Reversing in the sense the numerator became denominator, denominator became the numerator. Why? Because the sin A and cosecant A are reciprocal with each other. Then come to the secant A. We know that secant A is reciprocal with cos A. So the entire cos A values have been reversing here. Means the numerators became denominators, denominator became the numerator. So 1 is 1, root 3 by 2 became 2 by root 3, 1 by root 2 became root 2, 1 by 2 became 2 by 1, 0 became not defined. Why? Because they are reciprocal with each other. The cot A equal to the reciprocal of tan A. So again, this entire values have been changing here. So the 0 became 1 by 0, 1 by root 3 became root 3, 1 became 1, root 3 became 1 by root 3. Just reversing. Means numerator became the denominator, denominator became the numerator. Why? Because they are reciprocal with each other. So in this manner, we can easily find out the ratios of different trigonometric functions at different angles. The trick to remember is you have to remember the sin A values. For the cos A, the same values got reversed for the cos A. Okay. For tan A, we know that tan A equal to sin A by cos A. We simply make it sin A by cos A, then we will get the tan A values. For the cosecant A, we know that cosecant A equal to the reciprocal of sin A. So the sin A values got reversed. Secant A, the secant A is the reciprocal of cos A. So the cos A values will be reversed here. The cot A equal to reciprocal of tan A. So the tan A values will be got reversed. The ratios from the different angles. For example, we know that sin 0 degrees equal to 0, sin 30 equal to 1 by 2, sin 45 equal to 1 by root 2, sin 60 equal to root 3 by 2, sin 90 equal to 1. So in this manner, we can rewrite sin inverse of A equal to 0 degrees, sin inverse of 1 by 2 equal to 30 degrees, sin inverse of 1 by root 2 equal to 45 degrees, sin inverse of root 3 by 2 equal to 60 degrees, sin inverse of 1 equal to 90 degrees. Not only the sine functions, any trigonometric functions can be expressed in this manner. For example, tan inverse of 1 by root 3 equal to 30 degrees, secant inverse of 1 equal to 0 degrees, cot inverse of 1 equal to 45 degrees. So in this manner, we can easily find out the ratios from the different angles, also angles from the different ratios. So this is all about trigonometric ratios of some specific angles. See the note point here, sin A increases from 0 to 1, cos A decreases from 1 to 0. You must remember the above table. Okay. Without remembering the above table, we cannot even solve the basic problems in the trigonometry. If sin A minus B equal to 1 by 2, cos A plus B equal to 1 by 2, from the given data, sin A minus B equal to 1 by 2, cos A plus B equal to 1 by 2. The same expression can be rewrite as sin inverse of 1 by 2 equal to A minus B. Okay. Why? Because, for example, if sin 30 equal to 1 by 2, I can rewrite it as sin inverse of 1 by 2 equal to 30 degrees. In this manner, I am rewriting this term with different, I am rewriting this term in different manner. So, the sin inverse of 1 by 2 equal to A minus B. From this expression, the cos inverse of 1 by 2 equal to A plus B. Okay. I'm just changing this format into this format. Okay. From the above table, we know that sin inverse of 1 by 2 equal to 30 degrees, cos inverse of 1 by 2 equal to 30 degrees. So what is sin inverse of 1 by 2 here? A minus B. So in the place of sin inverse of 1 by 2, I can place A minus B. Okay. Equal to 30 degrees. So A minus B equal to 30 degrees. Okay. In the place of cos inverse of 1 by 2, I can keep A plus B. Why? Because A plus B equal to cos inverse of 1 by 2. Okay. In the place of cos inverse of 1 by 2, I can place A plus B equal to 60 degrees. Okay. So in this manner, we got two equations here. So by solving these two equations, we'll get B equal to 15 degrees, A equal to 45 degrees. There are some other trigonometric identities, sin square plus cos square A. Sin square A plus cos square A equal to 1. Secant square A minus tan square A equal to 1. The cosecant square A equal to 1 plus cot square A. Keep watching Sigma e-learning Smart Way to Excellence.